Steve's Physics channel. I'm Steve, and in today's problem we're going to be looking at a 7 kilogram box that's going to be sitting motionlessly on a 50-degree angle, and it's going to be held there by a force that is parallel with the ground, and we want to know what is the strength of that applied force that's going to keep it so it's motionless. So go ahead, pause the video, try it by yourself, and when you're ready, resume and I'll show you how I did it. Welcome back. Hopefully that wasn't too bad. First thing I did to solve it was, as always, I wrote off to the side all of the known quantities that I know for this problem. In this case, we know that the mass is 7 kilograms, we know the acceleration due to gravity, and we know it's on a 50-degree incline with no friction. What we don't know is the applied force. To figure that out, I wanted to draw a force diagram, and the force diagram is pretty standard. We have force of gravity going straight down, we have the normal force going at an angle, and we have the applied force that's actually going perpendicular to gravity. Now normally I would say we should probably rotate this so that the normal force is straight up and down, but in this case we already have 2 out of the 3 forces that are perpendicular to each other, so why not just keep it as is, and we'll break the normal force up into its components of the x and y direction. Now also, it's important to note that since the box is just sitting there motionless, that means that there is no acceleration, and no acceleration means that the sum of the forces is equal to 0, which means that in the x direction and in the y direction all of the forces are going to add to 0. To solve this, we're first going to look in the x direction and figure out what all the forces are. We know we have the force applied in one direction, and we know we have the x component of the normal force in the other direction, and those two must add to 0, so they must be equal and opposite to each other, so we can set them equal to each other. Force applied is equal to the normal force cosine of theta. Now we have 2 unknowns in that equation, so we have to also look at the y direction. Again, we know the sum of the forces is equal to 0, and the 2 forces acting in this case are we have gravity going down and the y component of the normal force going up. And again, those two add to equal to 0, so they're equal and opposite of each other, which means we can just set them equal to each other, and now we have gravity, mg, is equal to the normal force times the sine of theta. So now we just have to rearrange, solve for the normal force, and we find that it's equal to 89.55 newtons. Now we just take that and plug it right back into the other equation to solve for the force applied. And when we do that, we find that the applied force is equal to 57.56 newtons. Hopefully that wasn't too bad. If you do have questions, please leave them down in the comments below, and I'll do my best to answer them. If you like this video and it helped you, please like and subscribe to my channel for more content just like it. And until next time, have a great day.